press pause and answer the question.
Now we're going from one of the easiest questions I've included straight into one of the most difficult. But it's not that difficult once you know the rules, so I'm really glad you're watching this. All right, so we say if 2a minus b equals 8, so we have this relationship of a to b, and we're wondering what the value is of 4 to the a over 2 to the b. And this is the correct answer. It's going to be 2 to the 8th. But before we get into all that, let's go over some rules for exponents that you almost certainly have learned before, but is absolutely worth learning again. And we're going to try to put it in your head by explaining to you how it's derived. I think it's a lot easier to remember. So if we have x squared times x to the 5th, that's equal to x to the 7th. And we can just try that out, right? We can say x squared is this. It's x times x. And x to the 5th is x times x times x times x times x. And if we multiply them together, we have x times itself 7 times, so we have x to the 7th. So we're just going to add the exponents when the two terms are multiplied. We have x to the 0 is equal to 1. So anything to the 0 is equal to 1. You almost certainly remember that. That's just kind of a hard and fast rule. If we have something that's a negative exponent, if we have like x to the negative 2, that's equal to 1 over x squared. So if we have a negative exponent, we can turn that into a positive exponent and put the whole term on the denominator. And likewise, if we have 1 over x to the negative 2, that's the same as x squared. So if we're taking from the numerator and putting it in the denominator, we multiply the exponent by negative 1. If we're taking from the denominator and moving it to the numerator, we also multiply the exponent by negative 1. So 1 over x squared is equal to x to the negative 2, and 1 over x to the negative 2 is equal to x squared. Now, if you see something like this, at x to the 1/3, that's essentially saying the cube root of x. So x to the 1/2 is the square root of x to the 1/3 is the cube root of x, and so forth. If we see something like x to the 2/3, it's still just x to the 1/3, but now we're not dealing with x, we're dealing with x squared. So we're going to take x squared and take the cube root of x squared. Now if we have x to the 8th over x cubed, well, we can just use some of the rules that we had before, right? So we can say x to the 8th over x cubed, and we can take that 1 over x cubed and we can bring it up here to the top as long as we turn it into a negative exponent. So we multiply the exponent by negative 1. So now we have x to the 8th times x to the negative 3. And we know from up here that that means we have x to the 5th. So anytime we have a ratio like this where we have x to the 8th over x cubed, we can just take this number minus this number and get the new exponent. Now if we have x squared and we take that to the 5th, then that's equal to x to the 10th, right? Because x squared just means x times x, and if we have 5 of them, 1, 2, 3, 4, 5, then we have 10 x's. So x times itself 10 times. So that's going to be x to the 10th. So if we have an exponent and then it's taken to another exponent, we can just multiply them. If we have 1 over x to the 4th, that's equal to 1 over x to the 4th. Because this first one is just 1 over x times 1 over x times 1 over x times 1 over x, which collapses down to 1 over x to the 4th. And importantly for this particular problem that we're working on now, if we have 25 to the 4th, that's going to be equal to 5 to the 8th. And we know it from up here if we look at this rule up here, because what we're saying is 5 to the 8th is 5 times 5 times 5 times 5 times 5 times 5 times, and so forth, until we get 8 of these 5s or 4 of these groupings. And each of these groupings we can turn to 25. 5 times 5 is 25. So 25 times 25 times 25 times 25 is just 25 to the 4th. And that's what we want to do for this problem. Anytime you see exponents and a fraction, we want to get those in the same format. So we have 4 to the a over 2 to the b, and we want to get that 4 into the 2 or 2 into the 4. And it's obviously much easier to get the 4 into the 2. If we change this 4 to the a over 2 to the b, and we call it 2 squared to the a, because 2 squared is 4, then we know from the rules we just looked at, we know from this rule, that's equal to 2 to the 2a. So we can rewrite this, and we can turn it into 2 to the 2a over 2 to the b. Now we're talking. Now what we can also do is, because of this rule here, we can take this fraction, and what we can do is we can just multiply this exponent by -1, and then bring it up to here, and then add it to the other one. So we can say this term here is equal to 2 to the 2a minus b. Now we're talking. Now, if you look over here, it says 2a minus b is 8. So we could just stop there and just say it's 2 to the 8th, and that is our answer. But you'd be forgiven if you said, in the middle of a test, I'm not going to happen to notice while I'm going through these calculations that I was at this exact value of 2a minus b, and it happens to be 8. Okay, let's assume you didn't happen to see that. So we'll do substitution. We want to figure out what b is in terms of a. So we have 2a minus b equals 8. And we'll add b to both sides, and we get 2a equals b plus 8. And we'll subtract 8 from both sides, and we get 2a minus 8 equals b. And so then we can take that and we can replace our b with 2a minus 8. So let's go over here and take that b, and we'll replace it with 2a minus 8. And so now we have 2 to the 2a minus 2a minus 8. And that gives us 2 to the 2a minus 2a plus 8. And these two a's cancel out, so we get 2 to the 8th. That's our answer.